Unit 1, Lesson 2, Creating Equations and Inequalities in One Variable. For the problem below, read each scenario and give the units you would use to work with each situation. So, I'm trying to decide what type of units, because when we're dealing with contextual problems, or in other words, story problems, our answer always has to tie back to the problem. So we need to understand what units and know that information when we have those applicable problems. So, riding a bicycle. This could be anywhere from, a short ride to a long ride. So, typically when we're riding a bicycle, we want things to be more like larger distances. So, my first inclination would probably be something like miles. Okay. Probably miles per hour. Okay, in the same breath you could also do kilometers. I think you could even talk about, depending on what type of ride, maybe even go with feet or meters. Maybe per second or something like that. That would work as well, I believe. What we want to stray away from is the smaller measurements, or the, really, really long measurements like light years. Okay. Rainfall during a storm. So now we're probably going to measure, how much water there is, so things like inches per hour would probably be a good one. Okay, or could probably even go centimeters per hour. Water coming from a hydrant. So now with this one, because you're going to have a lot more stuff like inches, centimeters, now we're thinking more about the flow here. So you could do something like gallons. And it comes out pretty quick, so per hour probably wouldn't be a very good one. So like per second, per minute, something like that. Okay, or maybe liters per second. That would work as well. Okay, watching caloric intake. So there's really only one that works for this one, because you're dealing with food, and food is measured usually in calories. And typically they measure it per gram, or I suppose ounce if you wanted to. So there are those ones. Okay, let's move on now. It says for problems 2 through 8, read each scenario, write an equation, and then solve the problem. Remember to include the appropriate units. So now we're dealing with, figuring out what these problems are, and then writing an equation and solving. So you need to buy a new tile for your kitchen. It measures 13 by 25 feet by 7.5 feet. 13.25. Did I say by 25? Anyway, 13.25 feet by 7.5 feet. What is the area of the kitchen that you have calculated? What is the most accurate area you can report to your hardware store in order to purchase enough tile? So, area, remember, is, we've got a kitchen here. Here's where it's a good idea to draw a picture to visualize. It's 13.25 by 7.5 feet. Okay, the area is the space in there, right? So area is length times width. Okay, because they only gave us 2 measurements, it's probably a rectangle, even though there's kitchens out there that have different shapes to them. Okay, so it would be area equals 13.25 times 7.5. So then we multiply that in a calculator, or by hand if you really, really want to, but I would grab a calculator, do that, and we end up with the area equals 99.375 feet. Remember, when you're dealing with area, you got to square the feet, so feet squared. So what's the most accurate area you can report to your hardware store in order to purchase enough tile? Well, this 0.375, most likely they're going to have their tile measured out to like a square foot or something like that. So you'd probably want to report it as 100 square feet, and then you'd have to cut some tile once you got to the edges. So you'd want to go over, you maybe even would want to do more than that, depending on how big the squares are, to make it work. So, alright, number 3. Zack watches TV 3 times as much as Joel. Joel watches TV 2 hours a day. How many hours a day does Zack watch TV? So, what don't we know? What do we know? Okay, we know that Zack is watching 3 times as much as Joel. We know exactly what Joel watches. He watches 2 hours a day. So for Zack, we could do like Z for hours Zack watches. Okay, and we know that Zack's is equal to 3 times as much as Joel. Remember, 3 times in math means timesing by 3. So we take the 2 hours and we times it by 3. We triple it. Then that's easy enough to solve, right? So Z equals 6. So Zack watches 6 hours per day of TV. Okay? So number 4. It costs Raquel $5 in tolls to drive to work and back each day. Plus, she uses 3 gallons of gas. It costs her a total of $15.50 to drive to work and back each day. How much per gallon is Raquel paying for her gas? How do you know? Alright, so once again, we know that it costs $5 to just pay the tolls, which is probably something fairly unfamiliar for most of us around here. We don't really have any toll roads, but especially back east, they have roads that people have to pay for in order to use. Okay, so plus we know she uses 3 gallons of gas. Okay, we know the total cost, but we don't know how much per gallon she's paying for her gas. Okay, so we could call that G maybe. So gas money, essentially. So if we knew how much the gas cost, we would just times it by the 3 gallons, right? So we're going to go 3 times G. Okay, that would get us the cost for her gas. But we have to include the tolls in, so we're going to add 5 to that. Okay, and then we know that that's equal to $15.50. So now we just solve. So we subtract 5 from both sides. That would give us $10.50 equals 3G. Divide by 3. So 10.5 divided by 3 would give us 3.5. So she uses 3.5 gallons, okay, of gas. Oh wait, no, it was cost, wasn't it? Right, remember, gotta remember what the G stood for. Not gas, the money. So I could write it probably a little better. So 350 per gallon is how much it's going to cost her. Alright, number 5. Hayden bought 4 tickets to a football game. He paid a 5% service charge for buying them from a broker. His total cost was $105. What was the price of each ticket, not including the service charge? Okay, so we don't know the price of each ticket. We'll call that T for tickets. Price. Okay. We know that he bought 4 of them. We know that the total was 105. So I know that 105 is going to equal the rest of it. Okay. We know that he had 4 tickets, right? So we multiply the price per ticket by 4. But we also have to add in that 5% service charge. Okay. So because it's a percent, it's based off of our original. Okay. So we'd go now 5%, remember, it'd be 1, 2, so it'd be 0.05 mathematically times those 4 tickets. Okay. Then to simplify this one, we can simplify that first because it's multiplication. So 0.05 times 4 would give us 0.2 times T plus 4t. So now these both have t, so I can add them together. So 4 plus 0.2 would give us 4.2t equals 105. Now to get the cost per ticket, we would divide by 4.2. So 105 divided by 4.2 would give us an answer of 25. T equals t. So what does that mean? Remember, it was the price of the ticket, so $25 per ticket. Alright. So, number 6. It costs Justin $100 to have cable TV installed in his house. Each month he pays an access fee plus tax of 7% of his monthly bill. After 6 months, Justin has paid a total of $350.38 for his access fee, taxes, and his initial installation. What is Justin's monthly fee, access fee, not including taxes? So once again, what's his monthly fee, right? So we'll call it M for monthly fee. Okay, now let's break down what we have. We know it cost him $100 just to install. Okay, that's a one-time fee. We know that he pays 7% of his monthly bill, and we know that after 6 months of paying, his total was $350.38. So I know that $350.38 is my total. So it's equal to, that figured into that was the $100, right? We added that on. Then his monthly fee in 6 months, so 6 times M, would get us that part. Now we just figure in the percentage. So to figure that percentage in, it's kind of like what we did up here at 5. We're going to add 7% would be 0.07 times 6M, because he has to pay per month. Okay, so then we would simplify this. Okay, we typically like to get the M's together as we're simplifying. So 0.07 times 6 would give us 0.42M plus 6M plus 100 equals that guy. So now I combine those, so we get 100 plus 6.42M equals 350.38. There's my formula. Then to solve it, we first start by subtracting 100, because we want to get the M by itself. So 6.42M would equal 250.38 divided by 6.42 to get our next answer. So 250.38 divided by 6.42, and that gets us $39. So 39 equals M. So his monthly fee is $39, not including the taxes. If we include the taxes, we times it by 0.07, and it would be $2.73. So 39 plus $2.73. He's actually paying $41.73 per month, but that's with the tax, that 7% tax included. We didn't want that. We just wanted the 39. So $39 per month. Alright, on to number 7. You and 3 friends divide the proceeds of a garage sale equally. The garage sale earned $412. How much money did you receive? So let's do M again for money. Okay, so that's what we don't know. Okay, what do we know? We know we earned a total of $412. And we know that it was us and 3 friends, so there was 4 people total. So how much money each of us received times all of us is going to give us that total. So 4 times M. So we divide by 4. And M equals 412 divided by 4. $103 each. Not too shabby. Per friend. Okay, number 8. The area of Sophia's herb garden is 1/8 the area of her vegetable garden. The area of her herb garden is 6 square feet. What is the area of her vegetable garden? Okay, so we want to know the area again and of her vegetable garden, so we'll call that V, right? So the area of her veggies. So, it says the herb garden is 1/8 the vegetable garden. Okay? Her herb garden is 6 square feet. So, in order to find this, we would go V equals the 6 square feet, and we're going to multiply that by 1/8. Okay? And that's going to get us the area of her veggie garden. So we multiply that in our calculators. We come up with 0.75. Okay? And I'm thinking about this backwards, aren't I? It was actually her herb garden is 1/8 the area of the vegetable garden, so we'd have to do it backwards. 1/8 times her veggie garden would equal the herb garden, which is 6. That's better. Now to get rid of that fraction, we're going to have to times by 8. Okay? Because those will cancel each other out. We'd be left with V equals 6 times 8, which is 48 square feet for her veggie garden. Okay, number 9. Driving to your friend's house, you travel at an average rate of 35 miles per hour. On your way home, you travel at an average rate of 40 miles per hour. If the round trip took you 45 minutes, how far is it from your house to your friend's house? Alright, so the first thing on this one to notice is we're talking in miles per hour, but that's minutes. So we want to change this to minutes. Okay? So the way to think about that is 1 hour is 60 minutes. Right? So, we would go like this. We'd make a ratio. Okay, 1 hour over 60 minutes is equal to how many hours over 45 minutes? Okay, and then when we set things up like this, to get that by itself, we'd multiply both sides by 45. Okay, make it a fraction. 1 times 45 is 45. So 45 divided by 60, which would give us 0.75, which is how many hours 45 minutes would be. So that's really like 0.75 hours. Okay, so now we've got the same units. Now we can look further into this one. Okay, now remember we're traveling the same distance here, right? And so we want to know the distance, how far it is from your house to your friend's house. Okay, so we could call that distance, right, D. The distance to your friend's house. Okay, and that's the same distance whether you travel, both ways you travel. Okay. So, when we know the distance, now in order to figure this one out, we're going to have to think through it a little differently. And there's a formula for distance. It's called rate times time. Okay? We have the time for the round trip. We don't have the time for each trip. Because we're going at different speeds, our rate was changing. However, the distance we traveled from both of these is going to be the same. Okay? So that's where I can start an equation. Okay, I know that if I go 35 times the amount of time it took me to get there, okay, that's going to be equal to my rate of 40 times the rest of the time, the leftover time. We know that 45 minutes was 0.75, so if I go 0.75 minus this original time it took me, that's how I can set up an equation. I can figure out the time. Once I have the time, I can just multiply it by one of these to get our distance. Okay? So I'd have to multiply that in through, distribute it. So 35t equals 40 times 0.75 to get 30 minus 40t. And we can add 40t to both sides. So we get 30 equals, because that cancels, 35 plus 40, so 75t, divide by 75, so we'd get 30 divided by 75, so 0.4. So that stands for the time it took me. Okay? Okay, now because we had the 35t over here, not the subtracting it from, we'll use 35 and go 35, our rate, times the time 0.4. That's going to give us the distance. So 35 times 0.4 would equal 14 miles. Okay, so a very complex one, huh? So let's take a look at number 10 now. Okay, this one's another kind of crazy looking one. Two trains heading toward each other are 400 miles apart. Okay, so if we need to, we can visualize this. So we've got two trains. Okay, apparently we have two tracks, hopefully. Okay, they're 400 miles apart. One train is traveling 15 miles per hour faster than the other train. Okay, if they arrive at the same station in 5 hours, how fast is each train traveling? So, we've got the station here. We've got this one's traveling at x speed. That's what we don't know. Okay, so if that one's x, the other one is 15 miles per hour faster. This would be x plus 15. Okay, and we'll say x equals, the speed of the train. So this 400 miles is going to take 5 hours, we're saying. So now we've got to connect this for our stuff. So once again, we can use that distance formula, rate times time. Okay, do we know the time? Yes, it's 5 hours. Okay, is the speeds in hours? Yeah. Do we know the distance? Yeah, 400 miles. Okay, and we're trying to find the rate. Okay, so the distance would be 400 equals, the time we know is 5 hours, so 5 times. Now the rates are going to be both these rates added together, since there's two trains both coming in. Okay, so we'd go x plus 15. Then we can simplify this. So inside the parentheses, that becomes 2x plus 15 times 5 equals 400. Then we distribute the 5. 5 times 2x is 10x. 5 times 15 is 75 equals 400. To get x by itself, we subtract 75 to get the 75 to be gone. So we get 325 equals 10x. Divide by 10. We end up with 32.5 equals x. So that means one of our trains was traveling, this one, 32.5 miles per hour. Which means the other one, we add the 15 to it, and that gives us 47.5 for our two trains. And there we go.